Hello, I'm going to present the Flash bootloader, which is a software for updating automotive electronic control units which are built using Aurix tri-core microcontrollers. It's built to be easy to use in the field, while also optionally offering detailed diagnostics to use during development or troubleshooting. The goal is to get software binaries on the left onto the microcontroller's flash visible on the right, and it consists of the Windows GUI, which is written using Qt, and is connected to the CAN bus using a vector USB CAN interface, and the embedded part is running on a tri-core 375 dev kit that we're using. The software uses the Unified Diagnostic Services standard on top of the ISO TPA transport protocol for communication, and there's multiple checksums to guarantee a working device after every update. It's also written with extensibility in mind, so it can be adapted for other microcontrollers and bus systems. Here you can see the hardware. On the bottom left, the LEDs are currently off, indicating it's in bootloader mode, and after 5 seconds they start flashing to indicate the running application software. When resetting again and connecting using the UI, the LEDs blink slowly, indicating CAN bus communication with the bootloader. Now for the UI, we can switch the mode to the professional mode, which includes a console for additional troubleshooting. When refreshing the ECU list, you can see our dev kit gets detected, and we can select it, and the green indicator shows that it's running. On the console, you also see the current communication on the CAN bus, and it's possible to reset the ECU from this UI. Now we can choose a binary file, which is usually in the S19 format because it contains all of the necessary information and the user doesn't have to enter any additional data. You can see it's validated not only with the checksum, but also against the microcontroller. Here we can see we need to confirm which version we're flashing from and to, and you can see the data being sent in the background. Before flashing, as I mentioned, the file contents are verified with a CRC checksum, and after flashing, the flash in the microcontroller is compared again with the file we wanted to flash. Only if that succeeds, we set the key marker in the flash, and that indicates to the bootloader that the flashing process was successful and the application can start. If this key doesn't exist, the microcontroller will stay in the bootloader mode and the user gets another chance to try the flashing process again. This ensures that there's no brick devices ending up in the field, and that the flashing process always ends up reliable or aborts. That's it for our presentation, and we end this with the finished flashing of the microcontroller. Thank you very much for your attention.